In the last exercise, we have tried out the use of the light and the 3D rendering of the particle system. And in this enhancement, we would like to combine what we have done in the motion tracking or motion detection of the previous exercise. So if you remember, we have used a graphical character like the Winnie the Pooh to follow the movement of the user in front of the camera. And we'll apply the same techniques and try to put it in an integration with the particle system, and we'll try to have a look of the overall effect. So if you remember what we have done in the Winnie the Pooh exercise, we have used a full screen video, and by means of full screen, which is the full display in front of or within the graphical window, the gem window. It is 800 by 600. So what we are going to do is to create this one with the video, and then in the end it will be mapped as a texture in a rectangle. So we have done some sort of measurement in terms of the size of the rectangle, which is a 4:3 aspect ratio, which occupied the whole 800 by 600 window of the gem display. So this is the end result we would like to achieve. And you can also notice I have put in the gem head for the particle system and the video. So this one will be on the bottom 50 with the smaller size, and the 55 will be on top of this particular video. So the displays for this one will be like this one, and you can tune the parameter of each of the parameter in the particle system. And also the lighting effect. So at this point, the particle system will move on top of your background video. The next step is we would like to have a look of the information in front of the video. So that is the movement information. So we'll try to refer the original exercise we have done in the last couple of tutorials, and we'll use the pixel movement. So before sending to the pixel movement, we'll use the pixel RGBA to ensure the video information or the image information coming towards the pixel movement will have the alpha channel. And again, we'll use an horizontal slider with a value range from 0 to 1. As a parameter to control the movement tracking. Then we have the alpha blending. And finally, we'll go to the Prix block. And with the Prix block, we're trying to locate the movement of the user in front of the video. And the result will be showing in the two number boxes. The first one, that's the second outlet, and also the second one, the Y, is the third outlet. So we do not use the last one, which is the size indicator of the moving block. And for the block tracking, we'll use the number 4th channel. This is the alpha channel. So we have a combination of 5 of them. We use the last one, which indicate we're going to use the alpha channel as the indicator of the frame difference between the two consecutive frames. This part of the page we have done in the last exercise in order to track the movement of the user in front of the webcam. And the result will be shown in these two number boxes. And the values of the two number boxes ranges from 0 to 1, which indicate the respective or kind of normalized indicator within the window of 800 by 600. So the second point is, which is similar to what we have done, is we try to scale up this number within the range of the three-dimensional coordinate system. So that is in the left margin we have minus 5.33, to the right margin positive 5.33, and also in the y coordinates, the top will be 8. So the top will be positive 4, and the bottom will be negative 4 in a range of 8. So we are going to do the modification or scaling up of those x and y coordinates. For the x, we will do a multiplication of 10.66 and then minus 5.33 to make sure the center one is 0. And similar case for the y-axis. We'll minus 8 for this one because the direction is reversed. And for this one, we'll use positive 4 because of the opposite direction. So in the use of the coordinates, we turn by Prix blocks. So the top one will be 0 and the bottom margin will be 1. But in the coordinates of the three-dimensional space, so the bottom one will be minus 4 and the topmost margin will be positive 4. And after we perform the calculation, the two of them will show you two numbers. The first one is the x coordinate, so that will be a number. The second one will be the y coordinate of the position of the point in the three-dimensional coordinate system, which indicate the movement of the object or the user. And similar to the exercise we have used, for example, we need to pull to follow your movement. And in this case, we try to enable the particle system, and we try to attract all those particles by the movement of the user. So in that case, we'll make use of these two numbers and try to fit it back into the particle system. And if we take a look at the particle system over here, there's only one place at this point of time, which indicates a point in the three-dimensional space system. And this point is the orbit point. So we will use the orbit point as the center point to attract all those particles toward this point. And at this point of time, we have hard-coded the point coordinates at 200, which is a fixed point in the space. And in order to make use of the motion tracking, we will try to remove this point and set up another point over here as an inlet and try to fit in the coordinate from here into this particular inlet. And because this particular inlet is expecting a number or point in a three-dimensional coordinate system, so in that case we will also add in the Z dimension, which always be 0 at this point of time. And then what we are going to do is to combine these three numbers into a point in the three coordinate system and then fit it back to the second inlet of orbit point. The way to create this one is making use of the pack command. So pack is the opposite of unpack. And in the handling of the pick frame object, we have used the unpack to unpack a list into individual numbers. And in this case, we do the opposite. We try to pack individuals' number into one single list. So I've used the short form f, which is float, indicating a number. So the use of the pack with 3f, it will generate 3 inlets. Each of the inlet is expecting a number. So this is the first number, the second number, the last number. So after the pack action, it will return through its outlets a list. So this is similar to a message. And by pointing this one to the second inlet will enable, for example, the movement of the user in front of the camera as a point to attract all those particles to that location. So this is the way or the purpose of this particular patch. So we can also use a send and receive in order to streamline the connection. Like I send to the point P, so I use a short form P over here. And for this one, I receive the point. And also we have an 0 value over here, which is send message. So in fact, if you would like to enable this one in the beginning of the patch, you can do something we have learned called the load band. So whenever we load this particular patch or we open this one, the load band objects will issue a band signal along its outlet. And when it starts to load this particular patch, it will have a band signal to this message. And the band message will enable the sending of this value 0 to the last inlet of the pack command. So for other locations, if you would, for example, have a fixed number or fixed message in order to send in the very beginning of running the patch, you can always use the load band to achieve this purpose. Okay, so after that we'll perform the testing. I can also click over here because the patch is already open for a while, so it won't initiate the low band signal. So I can turn on the light to enable a three-dimensional display. And the other things is I select the alpha channel for the tracking and also adjust a little bit of the pix movement parameter. And you can try to move in front of the camera and then to observe the change in those values. So I've been using the pen to try to indicate the change in the x and y value of the moving point. So after that, you can try to enhance the behavior by tuning some of the parameter of the particle system. Like for example, you have the speed over here. You can also tune the force of the orbit point. So in that case, you can also use something to validate whether it is working properly or not. So the correct operation is, or a kind of optimal operation is, if you have moving objects in front of your camera, the particle will be attracted to that object. And the speed of the attraction and also the path is moving, you can use, for example, the speed parameter and also the force parameter in the orbit point object to control. So I can move away from the camera and then use some of the moving object in order to demonstrate the effect. So those are one of the example we can use, for example, by combining what we have learned in the motion tracking and also the particle system in order to manipulate the changes. So in this exercise, I have combined, for example, the location, that is the output from the motion detection, which give you the x and y value, which indicate the location you detect some sort of movement. And by combining this one with the use of the object point, so that is the position, which is the point you would like to attract all those particles to. And by adjusting the force over here, and also the speed and the number of the particles and the ages, so that will create an effect that you can use your body movement to attract those particles. So this is one of the demonstration. So we will look into other demonstration, for example, by using the second parameter. So we have made use of the position information in the object point right here. So in the next exercise, we can also look into, for example, the path source, which also have an position parameter, which is the location you would like to emit the particles, as a way to generate the particle source in order to align it with the movement of the user in front of the camera, which is returned from here.